Yes. Okay. So, as the slide which is up there also shows that the non-imaging processing is for things like pulsar search and pulsar timing, studying transients, and also recording the raw outputs for use for VLBI purposes. Okay, I don't think we have any further questions on the from either of the two for us. So we could now go into a slightly more general discussion about the software and hardware aspects of the participation from India. And I think one of the things that is probably interesting is that there's likely to be some overlap between these things, and which we should probably talk about in the sense that some of the motor control for the SKA law digital electronics will also may be more favorably developed within India, but we'll come to that. One of the issues I think both Prabhu and to some extent Yogesh, if you could address, is uh, not so much the procedural matters which we will talk about in the afternoon, but in terms of just the technological issues, that how does one propose to go about to set up and be ready to deliver these things. So Prabhu, do you want to say what kind of preparation we have to do in India in order to be ready to deliver these things, and what is going on right now? I think you're muted, Prabhu.
Thanks. Thanks for the question. I think what we are currently involved is related to, I'm just trying to see where the feedback is coming from. Sorry.
And maybe me, I'll just
The
mute
feedback is
myself.
coming from Yashwant. That's because you are the only two people who are not muted.
Okay, thank you, Ishan. Thanks, Yogesh. And one of the work that we have already begun doing is for these products, either the band one feed or the digital hardware, more so for the digital hardware, is industrialization of the hardware. To make the hardware manufacturable through an industry, which means the hardware should be fabricatable with minimal, surprises when it comes and when we try to assemble them, and when we, so that is a process that is currently that we need to get initiated. And also we need to identify industries who are capable of making these multi-layer boards of digital, the complexity that is required for the digital hardware, which has got about nearly 3,000 components and so on, and surface mount devices and so on. And also we would like to get certain industries to be talking to us, or we would be just conducting them to get these boards, early assembly of some of these boards. As a pilot study, we have already begun making one of the prototyping to get connected with the industry. We are already making a board which we call as an integrated prototype. So we began already getting ourselves and also the industry interactions start taking place in that using that project, so which is already happening. So what we also foresee is we would like to manufacture one or two of the few early prototypes, early boards, before they actually been given to a particular industry. We probably would like to get them manufactured by one or two different industries to get a feedback from how they come back, and also to understand the assembly complexities and so on. So we would get started on that. We may be discussing more on the intricacies and the complexity involved in the afternoon session. Similarly, for the antenna feed, and there will be a similar experiment will be done.
Yes, sure. We can, we can talk more about the procedural details of how we would do this with industry. My emphasis more was just even within the labs to get ready for being able to work with this technology, and that you have answered that we are both getting some prototype hardware that we will install, and I know that we are doing that both at NCR and RRI, so that people interested from within the entire SK India community can start working with this hardware, as well as the other point that you mentioned, which is to design a prototype board ourselves and get some further familiarity with the engineering that is required for doing these things. So I think that's good. And I think on the software side, I don't know if Yogesh wants to comment, though we have already discussed the fact that we have developed a Tango-based motor control system already for the JMRT, and there are team members from there who are on this call, and that is being used as a way of getting familiar with the techniques and for doing things. But you want to add anything further on
Yeah,
that,
yeah. I
Yogesh?
just wanted to make people who are not familiar with what is happening right now. So, for the observatory monitoring and control system software, we've actually worked quite extensively between about 2014 to 2018 to develop the detailed design of what was then known as the telescope manager. Uh, this went through several review processes that are mandated by the systems engineering process. It culminated with a critical design review in April 2018, which we cleared. And as was mentioned earlier, we were one of the first consortia to clear their element level critical design review. Since then, since it was already known at that time that it will be some years before construction can commence. Uh, a new phase was introduced in SKA, which is called the bridging phase, and it applied mainly to software development. And both for the OMC software as well as the science data handling and processing software, teams were set up to start some of the developmental activity, perhaps by making proof of concept softwares, uh, uh, and such prototyping of the software was done over the last 2 or 3 years. So we have been quite heavily involved in this process. We have one team at NCRA during the bridging phase, which has about 7 or 8 members, which has been continuously at work for the last 2.5 years. We also have smaller contributions to some of the other teams. For example, we have contributions to people who are starting to develop the user interfaces for the various stakeholders that I mentioned. Our team is mainly focused on what used to be called the telescope management component. This is the component that uses Tango to actually create Tango devices and talk to each other. So our team has created Tango-based prototypes for various devices. So there will be a device at the antenna base station where a signal will be sent from the central node of the system, and then some command will get executed, and once that command is executed, a message will come back saying that yes, the command has been successfully executed. So we have been able to create, using the Tango framework, prototypes of this nature, uh, which are as realistic as we can possibly make them without having access to to the actual hardware. So there are often some kind of simulators which are running on different computers. So you send a signal, and then there is a simulator which runs, which basically may ask, for example, to slew a dish to a particular position on the sky. And then there are additional signals sent for the dish to keep tracking the radio source once it acquires it. So all of those things have been already written. They've been demonstrated by our team. So when we move to the next phase, to the construction phase, we already have a well-trained, well-experienced team, but we have only one team at the moment and 3 or 4 people in other teams. What we will need to grow out is what I will discuss in the afternoon, to about 4 teams, development teams, which will involve a considerable increase in our number of developers. But I think we are well prepared because the 7 or 8 developers that we have had over the last few years, many of them have stayed on with the project throughout. So we have fairly experienced developers who are already available and who will be then put on to the next phase during construction.
Yeah, okay. Thanks, Yogesh. I'm just trying to see if there's anybody else who wants to open any other uh, topic for discussion. Um, Otherwise, I was going to open one more topic for discussion, which I would like to see what Prabhu and Yogesh have to say, which may be of interest to the slightly wider community, which is that as we are working on developing these different hardware and software items for the SKA as part of our contribution, is there a possibility that what we are developing can be used within the country for benefiting any of the other activities? Which may even include that even as you build up some of these and test them, whether they can then provide test beds for systems that could be built and used in the country. And maybe you just start with the hardware aspect and see, Prabhu, what do you have to say about that? Because I know there are people who have interest in building low frequency stations in the country, and I know there are discussions ongoing. Unfortunately, the relevant people who have been involved in the discussion are not on the Zoom meeting right now. They were there earlier in the morning, but these are things that have been of interest. And what would you say about the possibilities for this kind of development arising from this work for the SKA?
Thanks, Ishwan. I think this is one of the area that we really want to. I think there is a feedback, but I think that, yeah, thanks. So one of the thing that will happen during this development process of, particularly when the industry is engaged in making these products, there is a transition period during which our members will be heavily involved in transferring the knowledge to the industry. And beyond that, we do have expertise within the institutes, and also the products that are being produced in India could be built, especially towards even developing some next generation products, which may be of use for the even SKA, not just SKA, but having local instrumentation in India. Uh, in line with the observatory development program of the SKA, which Yogesh pointed out in the morning talk. So the hardware and the electronics and connecting them together would really bring in a new breath into building something that SKA probably is not having today. For example, the SKA low currently have maybe up to 48 beams at the station level. But while doing so, they do have sacrifice. They will have to sacrifice the bandwidth. They have to sacrifice the 200 megahertz band to 48 chunks to even feed the signal to the correlator. So these are the areas that we will be able to look at it, especially 100 gigabit Ethernet is now becoming common, which is right now not part of the SKA design, probably will get into SKA. And similarly, we are also working on areas such as the RF FPGA chips, RF SoCs, and we also are looking at high-speed data capture up to several gigabytes in a transient buffering mode. And we are also looking at possibilities of doing calibration in a new way, especially for SKA low. It will impact a lot of new modes probably that the SKA current hardware cannot cope with. And it is possible very much to test and try these things on our own ground. GMRT is one place, but we don't have the SKA low like capability in India with dual polarization and a similar bandwidth coverage. So it's not very huge. A station is just 4 times all 4 sides the MWA tiles. So it's very easy, and it's not going to be expensive experiment to build these capabilities in India. So we will be able to establish a couple of stations equivalent to that of SKA low. That will help our Indian engineering and science to grow on our own ground, and will stay back in India after beyond the phases of the SKA building is over. And that will also give a training ground, an opportunity for the Indian participation for the next generation hardware. So by taking the leverage of being able to talk to the industry, being part of the modern electronics, we will go one more step next in building the next phase of the electronics. And that's very much possible. And that is folded in the planning of our uh, in-country R&D, although it may be across several institutes, maybe many members can participate. There is some amount of possibility exists in the in-country R&D to do such things. So I'll stop here to take any comments.
Yeah, okay. Thanks, Prabhu. Just let me see if there are any comments from anybody on those kind of aspects, because I think there is significant potential for being able to use some of these things for in-country developments. And the simple example is having SK low type of stations. So you have to just see what is the right kind of antenna that you would dipoles that you would connect to it for experiments, which can be very useful for monitoring of transients and other signs happening in the country. Similarly, I think even as I'm just waiting to see if there are any comments on this, the Pulsar search system that we're contributing to, it should be possible to use that on existing facilities, right? For example, and so there, I had one question which I also may have missed, that in the default Pulsar search configuration for the SKA, is acceleration search algorithms included, or is this still focusing on doing non-acceleration search, but on large number of beams and over a larger parameter space of
So the
dispersion?
default
And
SKA search includes the acceleration search on a limited number of dispersion trials.
yeah,
The non-acceleration search is applied for all the dispersion measures that they want to cover, whereas the acceleration search is tried only on a few dispersion measures. But by default, it is tried on every uh, field.
so so for example, if one were to do a system, say for the GMRT, which does multiple beams within the primary beam, and each one of them to be searched extensively, then these kind of developments could be useful for growing those areas, right?
Yeah, very much. I think it is because the way SKA pulsar search hardware is developed, it is agnostic about which where the signal is coming from, and it covers the range which GMRT covers in terms of the frequency. So the DM issues and everything are somewhat similar, and the bandwidths are comparable, 200 megahertz or 300 megahertz. So I think it is very much usable for our own case. So that also means we need to build a front end which is reasonably uh, similar in terms of the SKA channelization and beamforming aspects incorporated. So this is one area the integrated prototype kind of hardware can be programmed to fit the capabilities, functional capabilities similar to have even VLBI with MID or even any other aspects of the front end processing similar to the SKA or even better.
Yeah, okay. Thanks, Prabhu. I'm just trying to see if anybody has any related or additional comments or points of discussion that they would like to bring up.
Yeah, there is one more area, Ishwan, I just wanted to point out the machine learning. Maybe Yogesh would have mentioned it in the afternoon sessions. I think this is also another area that we do have a huge potential contributions possible, machine learning, and also related to the FPGA related signal processing, GPU related signal processing. So Indian community has a lot of contribution to the international groups. So we will be able to tap them for even local developments.
Yeah, we do have a talk scheduled today afternoon where members from ThoughtWorks, one of our industry partners, are going to discuss about applications of machine learning. And we've already started within NCRA and other places in India. There are already a few examples of applications of machine learning in various domains of astronomy, on the science side, but also on things like RFI flagging and so on. People are trying out machine learning based solutions. So we will discuss that in the SRC session and possibly in the last session as well. But I think this will become increasingly more important. By the time the SKA comes online, machine learning will be much more powerful than what it is today.
Yeah. So I see meanwhile that my previous point has triggered a few responses on the YouTube channel with questions from Lipshit Dash and from Hariharan about options. So can we have our own customizable system like SKA, not exactly, but similar to that with some customization? And Hariharan asking whether instead of a single station, a full-scale low-frequency array of 10 to 300 megahertz co-located with GMRT within the 3-kilometer core will be better. And so these are all related to the things. And I think the idea is exactly that getting into these kind of areas of work with the SKA will open up the various possibilities. And I know there is already some discussions ongoing about planning for low frequency dipole based systems, which could be located, maybe co-located in GMRT, co-located at other places where it is relevant infrastructure is available, but all of which would then utilize this expertise and experience that one is gaining from building some of these things with the SKA. And Hariharan again asks that existing infrastructure of OFC at GMRT, yes, all of can be reutilized. All of that is being thought about and talked about. And that would really be an effort where there would be some synergization of the existing knowledge and expertise and the new things that one is gaining from the participation in the SKA. So certainly, and these are things that, the whole idea is to open up this so that wider community in India can then think about possible projects, and it could be individual institutions or it could be collaborations of institutions that come together and want to embark on something new, which utilizes all of this. So certainly we expect that this should trigger some of this kind of activity.
Can I add one comment, Ishwan?
Go ahead, Prabhu.
Yeah, thanks. Yeah, I just wanted to say, just looking at the YouTube chats, I think we are working on one of the most modern FPGAs, 10 nanometer technology, 13 nanometer technology. Currently, that is part of our integrated prototype development. So we are actually getting the industries pushed. We are pushing the industry, and they are in turns helping us to get information to develop things. So currently, we are at the fore end of the technology in terms of digital, and I'm sure even in RF, because people have been doing so much sophisticated RF electronics building, both in GMRT, RRA, and other IAA kind of areas. So we are not actually behind technology in terms of radio astronomy instrumentation building. So based on this fact, in terms of even machine learning, our young engineering students have contributed to SKA, even in the pulsar search work. So this is happening. And so what we want to do is use this pitch. We are running at the right pace. Use this pitch to go beyond SKA. We don't have to be limited by the exact configurations and plans that of SKA, which happened 10 years ago. The baselines probably will evolve as the time progress. The in-country developments can in fact go and exceed in the specification range and capabilities what we probably see in elsewhere, although this is SKA specific work, but we don't have to be limited by the specification set or anything that has happened because of the timeline and cost constraints. So we can empower better capabilities with new thinking and whatever lessons that we learned from our current work. So that's one thing that I wanted to say.
Okay, so I think that's been useful discussion covering these possibilities and prospects. And I'm just seeing if there is any other point that is being raised.